Okay, hello world. In my hands I have an neodymium magnet taken from a hard disk drive and a little piece of spring coil. I hope you can see that. Now, if I drop it, it would just go down as usual. But if we have a magnet placed and it's going to drop nearby, which I will try to demonstrate, it will travel quite far. You can see that. I hope you can see that. It's under the keyboard. So what happens is that if it goes down nearby the magnet, there are two cases. Either it just travels onto the magnet and gets magnetized while falling, or it will slide under the magnet and accelerate, which it did earlier, and will fall somewhere under the keyboard. Well, in my case, in the keyboard. And that's quite a distance. So I don't know if the camera is showing that. I will try to record this once again. So here it goes. Oops, now it's traveled way too far. So this is, okay, now you can see my left hand and it's going directly onto the magnet. And if I'm far enough from the magnet, it's going to, slide under. Yeah, which it did again. And it traveled. Okay, now even I can't find it. Now even I can find it. Oh, here it is. It just bounced back and fell somewhere around here. Hit the keyboard and bounced back. Okay, so this is how it travels. What I have done is that I have drawn a little schematic of what I observed. So here's let's imagine that this is the small spring coil which I had. Yeah, so let me just grab it. So this is our spring. In the under usual circumstances, it will just, fall down under the force of gravity, which is F equal m times the free fall acceleration. But if we have a neodymium magnet, which is this thing, so here's the coil one more time, and this is the magnet. This time there are three chances. If it's three chances of it falling down. If it's far enough, it will fall by the same token as it did in this case. But if it's very close to the magnet, it will get magnetized and land on a surface. So sorry, my pencil is also metallic, so it just magnetizes onto the magnet. Gets attracted. Okay, and if it's the right distance, here we can see that it is falling, and there is a magnetic force pulling it onto the magnet, but it's not falling down. It's actually deviating or sliding under the magnet. And this is the moment when it gets really accelerated. This is the highest momentum. I can't show it on the video, but you can try this by yourself, and I hope you will observe this. So the vector, it's changing its vector and it's going, sideways. And so I was also wondering about the alien stuff, which is, non-believable, let's say like this. And so I was drawing a little graph of the, the saucer and how it, probably could have been built. So this is, imagine that we generalize this to a saucer and we have neodymium magnets or superalloy magnets like neodymium on the sides, and we have something like Tesla coil in the middle, and the whole thing is spinning in circles. So it's a circular spin. So the electron flow could, by the same token as here, travel by the magnet and sort of, fall, but they do not fall. They accelerate on the side, and this is what probably could make the saucer, fly or move or rotate. I don't know. This is just me speculating and theorizing, and I'm just drawing and imagining. I don't have the real experiments. And so once it's spinning, the flux, it's not stationary. The flux from the Tesla coil or any source of high voltage, if it's spinning, that it's not meaning it's not stationary. And this, if the plates are also spinning, it means that the electrons would constantly be accelerated under some certain angle, and this is what could provide the lifting force. So here's another schematic of it. So it's kind of a mini Tesla coil, and so the flux lines would be going around. And if the object is staying on one spot, then nothing happens. But if it is, spinning, and the plates are spinning, so it would cause, the electrons also to deviate and provide maybe some lifting force, or create its own, magnetic field. I know that this sounds a bit ridiculous because the flux does not create any force of motion or any motion whatsoever. I'm just theorizing. Maybe if the voltage is high enough, then it creates the field, which can be used as for motion. Much like I see it as, if mass creates gravity, it's Einstein's rule that the higher the mass, the higher the gravity. So by the same token, I was, imagining that if only we have enough electrical power built up here and enough electrons that could flow, and deviate, then this would create the motion or the lifting. Now, I was also thinking that the source of electrons could not be just space, because there is not enough, even if given that we have enough electrons in the space, it's still not enough. So I was wondering if there is something like a Tesla coil on board, or any source which could provide for that. Okay, and this is the mock-up that I have built. Let me just take it on the left. So this is the mock-up which I have built. It comes from the hard disk drive, much like the neodymium magnet. It's the motor, and this is the transparent disk. And so I was imagining that somewhere around here would be the Tesla coil in the center, and then the magnets could be, placed around the disk. And so once it rotates, you can see this. So it's rotating, and the electrons that are coming or built in the center, they would travel downwards and slide under the magnet. And this could provide for a very, possibly good spin. What do you think of this crazy idea? Of this very crazy idea? I'm just, searching. I'm not postulating anything. I'm not even a physicist, but what do you think about it?